Welcome to Goldfish on Games. The bid has been released and so has version 0.4 of MegaAtoms. You can download it in all the usual places with links in the description if you don't know. But before you go running off and grabbing it, you might want to hang around. So I'm going to go over what's changed, and there's going to be another development deep dive into one of its technological features. So let's get into it. Despite starting off with the plan I'd set down in the last video, I quickly strayed from it and started to implement the features that I really wanted to work on first. These included having a high score table for the challenge mode, which will be saved to SRAM if you're using an emulator or you have a flash card that supports it. This also meant I had to add a way of entering your name when you get a high score. I decided to use the classic 3-letter system. To aid with getting a high score, there is now a set of help pages. These will go over the basics of the game, and hopefully it'll be far more clearer what you need to do. In game, you should also notice you can pause the game, which is handy when life wants to intrude on your quest to get to the top of the score table. You can also pause in classic mode, which gives you that moment to plead with your mate as he's about to wipe you out. Classic mode also got a set of progress bars. Now these scale to show who has the most number of atoms on the board and gives you an idea of who you should be going for. And if you're interested in how these were done, then stick around for the development deep dive. Possibly the best change though was the fact that the amazing artist who did all the work that I've been hacking up to get it to fit on the Mega Drive has returned, and has updated all the professors and the robots so they look so much better. I love what he's done with the female professors. They are head and shoulders over what I had done. Finally, there was a number of other bug fixes and smaller improvements. These can be seen in-game and in the code, and if you're interested in the code, it can be found in its usual home on GitHub. Well, hopefully that's whet your appetite, and you're raring to go and play the game. If you have any feedback, good, bad, or bugs, or anything at all, leave them in the comments here, find me on Twitter, or put it on the GitHub page. I will respond to every comment that I get, because I want to know what you think of the game and how you think it might improve. And for those of you who are more technically inclined, well, it's that time again. In this development deep dive, I plan to look at how I managed to do the scaling bar for the challenge mode, as well as how I did the scaling on the progress bars in the classic mode, as they both use some similar ideas underneath the hood. First up, let's look at the challenge mode, as it's the more complicated of the two solutions, and it will lead us onto the progress bars quite nicely. Let's see what this looks like when we strip away all the other graphics and just look at the raw image that I load in. And as we can see, it looks quite different. And the bar at the bottom looks very odd. If we apply a grid to this, we can get a better idea of what I'm doing with the tiles, but we can get a closer look at the bar itself. Now you might notice something interesting. We have a 0 tile, a full tile, a 7 tile, 6, 5, 4, 3, 2, and a 1 pixel wide set of tiles. With these tiles, we can pretty much get a bar of any size we like and of any value. In this instance, we only care about this bar, which is 184 pixels wide, which equates to 23 tiles. With these values, we can then use a little bit of maths to position everything that we need. We're going to be drawing this to the map that's drawn on screen. So first thing we should do is just clear it. Now this doesn't change the underlying tile set, just what's drawn on screen. For the sake of argument, let's say our total time is 60 seconds and our current time is 36 seconds. This means we need to fill 60% of this bar, or 110 pixels. Now if we think of this in tiles, this means that we need to fill 13 tiles and then fill 75% of the last tile, which is easily done with our full tile. To get that 75%, we just calculate that out and it comes out to 6 pixels. So we look up our tile set and find the tile with 6 pixels and add it at the end. And there we go. Very simple, very straightforward, and it allows us to do quite cool things. Now if we update this every frame, we get what looks like a relatively smooth scaling bar. and by adding a colour fade as we hit halfway through the bar to yellow, and then a further colour fade from yellow to red once we hit quarter of the way, we give a real sense of urgency to this animation, and it makes it seem far more alive than it might have done before. Now, as we've seen, this is entirely done on the background. For the classic mode, we use Sprites. Now, it might seem weird to use Sprites, but I had some spare with this mode, so it was a bit easier. And we only need 3 sprites for each of the bars to draw it. We have the lower part, the upper part, and then a topper. And if we look at its sprite set, we see something very similar to what we had before. Now, this is using the same palette as the atoms themselves, so we needed to treat this in a very similar way. But the maths is almost identical. Instead, we use whichever player has the most number of atoms as the one that should be full, and then everyone else gets scaled from there. And there we have it. This development took a bit longer than I had planned, and hopefully the next one won't take anywhere near as long. But until next time, I've been the Goldfish, that is MegaAtoms, and this has been Goldfish on Games. And if you'll excuse me, I think I'm going to go and try and beat a high score.